Welcome to Mechanical Insight. Today's project starts with a heavy-duty truck tire, followed by a pair of smaller, compact front wheels, featuring stamped steel rims painted in contrasting yellow and black. The engineer uses a vernier caliper to measure the center axle diameter and set the parameters. Silence. An alloy hole saw then expands the center of the flange. High-strength, heavy-duty bolts are inserted. Silence. Moving on to machining the core spindle. A thick-walled cylindrical steel pipe is clamped securely in a vise. Industrial bearings are pressed precisely into the inner cavity. Silence. This axle pipe is immediately welded solid to the flange plate. Silence. The braking system begins to take shape. The carbon-ventilated brake disc is positioned, marked, and drilled with concentric holes. Silence. Every detail is aligned with microscopic tolerance. The brake disc is fitted tightly to the hub and securely locked down with nuts. Silence. This integrated hub design features a sturdy custom-built brake caliper, ensuring braking torque is evenly distributed across the entire rim. Silence. Next, fabricating the main spindle steering knuckle assembly. Thick U-channel steel is marked out and cut using an angle grinder. Silence. 2 through holes are drilled to support the vertical shaft bolts. A threaded steel shaft is inserted coaxially into the galvanized pipe. 3 TIG welds play a key role in connecting the U-bracket, the threaded shaft, and a protruding auxiliary steel plate acting as the steering arm. Silence. The 2 steering knuckle assemblies are perfectly formed. Silence. They are crucial load-bearing S in the suspension system. Entering the shaping phase of the front subframe, square steel tubing is measured, cut at 45-degree angles, and assembled into a trapezoid. Silence. A tack welding technique is applied to lock the frame's corners, completely eliminating thermal distortion before fully welding the seams. Silence. Two flap disc grinders remove welding slag and burrs, leaving the steel surface perfectly flat and ready for powder coating. Silence. The frame's torsional rigidity is reinforced by permanently welding 2 bent steel tubes along the main body. Silence. Now it's time to machine the central steering column housing. 2 large bearings are tightly pressed into the core of the heavy-duty steel pipe. Silence. This bearing-integrated cylindrical block is carefully leveled and welded firmly upright at the center of the chassis. Silence. Beginning the design of the geometric age tie rod mechanism. A steel plate is drilled with a large hole to fit over the central steering column. Silence. The engineer continues to cut and weld perfectly square steel box supports, integrating U-brackets and refining the surface with a TIG torch. Silence. Test fitting the tie rod and lever assembly using pivot pins. The complex steering geometry mechanism operates smoothly and synchronously. Silence. The engineer proceeds to assemble the U-shaped steering knuckles onto both ends of the subframe. Silence. The hinge pins are thoroughly lubricated. The 3 vertical shafts rotate flexibly within their mechanical housings, ensuring an accurate kingpin inclination angle for the steering system. Silence. The yellow and black front wheel pair is brought into position. All the locking nuts are tightened down using a pneumatic impact wrench. Silence. The main frame of the machine begins to take shape. Large industrial steel pipes are measured, cut, and carefully chamfered. Silence. The MIG welder continuously feeds steel wire, creating deep penetrating stack of dimes welds to bond the vehicle's backbone. Silence. Next is the rear swing arm. designed to handle a massive load. Thick rectangular steel sections are welded together into an H shape. Silence. The rear axle is precisely threaded through the center of the heavy-duty truck rim. Silence. A large drive sprocket is welded solidly to the axle hub. The rear swing arm is connected to the main frame via a universal pivot joint. Silence. This mechanical structure allows for an extremely wide range of motion. The heavy-duty monoshock suspension system is brought to the workbench. Silence. The shock mounts are heavily welded directly to the swing arm and the chassis. Silence. The internal combustion engine block begins to be positioned. The engine mounts are welded from thick anti-vibration steel gusset plates. Silence. The engineer carefully lowers the engine block onto the solid mounting base. High-strength steel bolts securely lock the engine to the chassis. The chain drive system begins to be aligned and assembled. The industrial chain, with a large pitch, is routed through the front and rear sprockets. An automatic chain tensioner mechanism using a compression spring is added to ensure optimal chain tension during operation. The steering system is completed with a custom-built handlebar assembly. The universal joint driveshaft transmits flexible rotational movement down to the steering rack. The steering tie rods are thread adjusted to balance the front wheel hubs. The Ackermann steering angle is accurately calculated and aligned. Now it's time to machine the hydraulic disc brake mechanism. The brake caliper is accurately mounted onto the aluminum bracket. 4 brake fluid lines with pressure-resistant steel cores run along the vehicle's body. The engineer proceeds to bleed the air bubbles from the system to create optimal braking pressure. The brake and gas pedals are plasma cut from anti-slip diamond plate. A high-elasticity spring mechanism helps the pedals return smoothly. The cylindrical galvanized gas tank is welded shut and leak tested. The fuel line and fuel filter are quickly and safely connected, threading the threaded rod radially through the core cylinder. The engineer continues to mount the remaining positioning flange, sequentially tightening the bolts on the flange. We immediately have a perfectly symmetrical dual hub system. A large drive sprocket is installed on the axle assembly. A wrench is used to tighten the lock nut system. The newly machined hub assembly is dropped through the center of the disc. Rivets and nuts are used to securely lock it permanently in place. Proceed to attach the brake rotor to the flange. The drivetrain and braking systems have now converged on a single axle. This entire core assembly is inserted into the drive wheel rim. Screws are fastened all around to securely fix the rim. Moving on to machining the load-bearing connecting brackets, using a square and a marker to accurately pinpoint the drilling locations. The combination of carefully chamfered square steel tubes forms a rear swing arm that is sleek, thick, and extremely rigid. After TIG welding, an angle grinder clears away the welding slag, leaving the swing arm surface smooth and flat. Integrating spherical rod end bearings into the ends of the fork, high-strength bolts are used to create a solid connection. Installing the swing arm onto the massive rear wheel axle, using a spirit level to fine-tune it for an absolutely perfect horizontal balance. Continuing to weld and secure the load-bearing truss positions. The rear swing arm structure has now achieved maximum sturdiness. Merging the machine, the front frame carrying the engine is pushed closely against the massive rear wheel system. The industrial drive chain is threaded through the sprockets. The engineer carefully adds a roller chain tensioner. The hydraulic brake caliper assembly is quickly positioned, ensuring safe deceleration for the entire rear wheel. Installing the master cylinder and brake pedal mechanism on the frame. All joints are continuously bolted and meticulously welded. Starting the process of fabricating the seat mount, using a V-shaped steel frame and a drill to securely bolt it in place. A shaped steel plate is carefully TIG welded to form a solid connecting bracket for the seat mount. The single-piece blue plastic seat is measured. The engineer cuts 2 flat steel bars, marks them, and drills holes for the mounts. The rectangular subframe is meticulously welded, integrating 2 vertical supports to form a lifting fork system for the driver's seat. The arc welding machine continuously secures the right angles. The seat base structure requires the ability to withstand sudden heavy loads. This lifting frame is tightly bolted to the bottom of the seat, then test-fitted onto the chassis using a wooden block. An angle ruler adjusts the position for perfect balance, radially drilling to insert the hinge bolt for the seat suspension system. R. Welded to the rear of the vehicle, it connects directly to the seat base. The independent secondary suspension system for the driver is now complete, ensuring it absorbs all harsh vibrations from the rear wheel. The inventor sits on it to test and check the compression and rebound travel. The spring's oscillation amplitude operates extremely stably. First, moving to the manual mechanical tube bender, the round steel tubes are bent accurately to shape the steering handlebars. Second, the extended V-shaped handlebars are rigidly welded together, becoming the steering control center extending towards the rear. Third, the handlebar assembly, after being powder-coated in an eye-catching yellow, is equipped with switch clusters, a throttle grip, and a brake lever, which is hydraulic. The engineer meticulously installs the master cylinder on the handlebars, routes the throttle cable, and runs the signal cables along the steel frame. The entire extended steering age assembly is mounted to the bracket. Heavy-duty steel bolts allow flexible rotation. The engine, electrical connectors, and throttle cable are accurately wired. The brake fluid lines are plugged into the hydraulic splitter. 4. Adding brake fluid to the reservoir on the handlebars. Squeeze and release continuously to bleed the air, pushing the fluid pressure down to the brake calipers. The rear brake line is neatly secured along the frame. Connecting directly to the brake caliper assembly, the massive truck wheel disc. 4. The mechanical foot brake pedal is fine-tuned for free play. Every braking mechanism from the handlebars to the foot pedal is absolutely perfect. 5. Installing a plywood board to make a sturdy footrest. Mudguard. The curved black plastic hugging the rear tire is attached. 6. The red long lever gearshift mechanism is mounted, extending straight from the engine block up to the seat base for convenient operation. The exhaust system is designed with refined curves. The chrome-plated exhaust pipe is tightly bolted to the engine exhaust port. A classic round headlight is securely mounted to the front. The taillight assembly with integrated turn signals sits neatly behind the seat. The wiring system is carefully routed through corrugated tubing. The 12-volt battery providing the central power supply is positioned in place. The positive and negative terminals are connected and securely fastened, filling the large capacity tank with gasoline. The creator settles into the driver's seat and turns on the ignition. The engine roars to life after a crisp electric start. The lighting and signal systems, including the turn signals, operate perfectly. With a slight twist of the throttle, the machine slowly rolls forward. The massive rear truck tire shows off its gripping power. Heading out onto the wide asphalt road for a practical test. The Ackermann steering angle allows for extremely precise and smooth cornering. 2. The dual-coil spring suspension system at the rear completely absorbs any bumps, providing a balanced and comfortable riding posture for the driver. 3. The vehicle's center of gravity is lowered to the maximum, effectively preventing rollovers. The sprocket gear ratio delivers powerful torque. The point-of-view angle shows the highly responsive tie rod steering mechanism. The front suspension has no shock absorbers, but operates very stably. The bold combination of a truck tire and a small motorcycle engine creates a highly creative, one-of-a-kind custom mechanical masterpiece that is truly captivating. The three-wheeled machine accelerates smoothly and darts away, concluding a spectacular fabrication project by the mechanical engineer. A pair of striking red hydraulic coilover shock absorbers